Hola! Welcome to Lecture 2 in Session 4 of this UNESCO Masterclass series on climate change and the Pacific Islands. In Lecture 2 we look at the nexus between climate change and sea transport as it affects Pacific Island countries and communities. My name's Peter Nuttall and I'll be taking you through this lecture today. So at the end of this session we expect that you will be able to firstly explain the nexus between climate change and sea transport, describe the importance of sea transport to the Pacific and its role in fuel dependency, and identify the challenges faced in this field. Pacific leaders have consistently identified two critical barriers to sustainable development. The first of those, of course, is the threat of climate change, and Pacific leaders have called for a threshold of no more than 1.5 degrees of global warming. To achieve this, three things are required immediately: rapid decarbonisation of the global economy, all sectors must contribute their fair share, and all countries, big and small, need to lead by example. Looking more at the local level, the critical issue that we face is the regional dependency on imported fossil fuel. This region is the most dependent region in the world on imported fossil fuel, 95%, greater if we exclude PNG and Fiji out of this equation. Of this fuel that we import, 70% plus is used for transport. This makes us different and unique in the world. Of course, this dependency is crippling for national budgets. It means that governments must spend money paying for imported fossil fuel that they cannot spend on other essential government services. And it makes the Pacific very vulnerable to changes and shocks in oil price and oil security. So let's look at the nexus between transport and climate change. At the international level, bunker fuels, which is what we call the fuel that we put into international ships and planes, have been excluded from the UNFCCC process under the Kyoto Accord. Under Kyoto, responsibility for bunker in shipping was passed to the International Maritime Organization and bunker for aviation passed to ICAO. Unfortunately, progress by both these two actors has been disappointingly slow. Transport is the fastest growing emissions sector. Currently around about 25% of global emissions come from transport. So international sea and air transport each contribute around about 3% of global greenhouse gas emissions. If we were to compare sea transport and air transport as a country, that would mean that each of these sectors contributes about the size of the country of Germany or Japan. But the real danger that comes from bunker fuel is that all business as usual modelling shows that shipping will increase by between 50 and 250% by 2050. That's about the size of Europe's emissions today. So continuing to ignore bunker targets would be like ignoring emissions from an entire continent. And if we do not set clear targets and achieve them within the transport sectors, it will make achieving a 1.5 degree target threshold unachievable. Now, when shipping, there is a very special issue for Pacific states that host what are called independent registries, more colloquially known as flags of convenience. A number of Pacific states host such registries, with the Marshall Islands being the third largest in the world, and its flag flies on round about 11% of the world fleet. So if we look at this graph, we can see between 2000 and 2014 that there has been an exponential rise in the volume of sea trade globally, from round about 30,000 billion tonnes in 2000 to now over 50,000 billion tonnes. And as I said in the previous slide, this is predicted to increase by between 50 and 250% by 2050. You can see in this map, 2012, the scale now of international shipping. So imagine this increase 2 to 3-fold. If we look at what must be done if all sectors are to play their fair share in reducing emissions, if we look at this graph, you can see that the black line shows where shipping was projected to increase a decade ago. The blue lines show the various scenarios under which shipping must reduce its emissions if the world is to stay under 1.5 degrees of global warming. The red lines show the various scenarios if the world was to stay under 2 degrees of global warming. Unfortunately, the dotted line shows the current trajectory for international shipping emissions. Clearly, this is unsustainable if the threat of climate change is to be avoided. So in May 2015, the Republic of the Marshall Islands, supported by a number of other Pacific states, called on the IMO to set an ambitious target for reducing shipping emissions commensurate with a 1.5 degree threshold. Unfortunately, the IMO rejected the call, stating that it needed to consider the outcomes from Paris. The Republic of the Marshall Islands is returning to the IMO in September, where there is a special intersessional session being called to examine the issues of fuel efficiency. In November, at the Assembly of the IMO, the Marshall Islands has submitted a further submission to continue the call for the IMO to set a clear target. This strategy needs to be endorsed by the Pacific community as a region if there is to be a regional voice heard to support the Marshall Islands initiative. Following on from the May decision of MEPC 68 at the IMO to decline the Marshall submission to set a target, delegates from both the Marshall Islands and Fiji called on the UNFCCC in the preparatory meetings leading up to Paris to reconsider the issue of setting targets for bunkers at an international agreement. Again, a regional voice is needed from all other Pacific Island states to support this initiative. There is strong support for the Pacific from the European Union. It is also an opportunity for Pacific states to show leadership to other small island developing states and indeed to the world. All sectors must do their fair share. Bunkers can no longer be ignored. Paris, of course, is only a milestone in a much longer journey, and the Pacific needs to consider what the long game is after the Paris Accord, and this requires a strategic regional strategy. So we say that transport is the forgotten sector. It's the largest of the fuel users for the Pacific Island countries. It transport three sectors: land, air, maritime, use around about 70 to 75% of all regional imported fossil fuel. However, it has been largely ignored to date in the current energy revolution being undertaken in the Pacific. So we reach the ironic situation where there is around about $1 billion of donor funding pledged today for the single purpose of reducing the Pacific's dependency on diesel. However, almost all of this is for electricity substitution. This is despite the fact that electricity only uses around about 20% of our regional fuel use. Some work is happening on fuel substitution, some work is happening on looking at alternative fossil fuels such as LNG to replace our reliance on diesel. However, unfortunately, for a number of complex reasons, the funding that has been currently pledged in this area is not for transport, it is for electricity. The Pacific transport scenario is quite unique. Shipping in particular and aviation are the lifelines of the Pacific. We cannot have connectivity without them. It connects our small communities with our urban centres, and it connects our countries to each other. We have the longest routes, the most narrow economies, minute markets. Shipping is high risk and low return. For us here in the Pacific, unlike the continental world where road transport is the biggest user of fuel and the highest priority, sea transport, followed by air, must be the highest priorities in the Pacific. Shipping is the absolute lifeline of all Pacific countries and communities. It moves round about 90% of all goods and is a significant mover of population. Without sea transport, we lose connectivity. Of the different maritime sectors, such as fishing, tourism, international trade, domestic maritime activity, it's the domestic connectivity that is the most critical sector. Ignoring decarbonisation of this sector is illogical and irrational. Current fuel bills are crippling and a major impediment to development for almost every Pacific Island country. The longer we leave a transition to low carbon, the greater will be the cost. As the world moves to decarbonisation and as means of transport become less fossil fuel reliant, if we do not act now and make the transition, we will face a double penalty because increasing international compliance costs will be met by increasing costs for running fossil fuel vessels. So let's look at this issue of the unique characteristics of Pacific Island shipping. The distances between our islands are long. There are very thin routes, minute economies, low cargo volumes, high freight rates, extreme financing barriers, and high infrastructural costs. This is an area of cyclones. This is an area of regular climatic disruption and activity. And our infrastructure for shipping in particular is highly vulnerable in these areas. If you're a small economy, as most Pacific Island countries are, and you have to replace your infrastructure due to cyclone damage on a regular basis, it becomes a very large drain on national economies. There's been a long history of the region struggling to find long-term, sustainable, cost-viable solutions for sea transport, even in periods of relatively low energy costs, and this is particularly true for domestic shipping. Ships are often old, poorly maintained, and inefficient. And fossil fuel is often the largest single operating cost for shipping operators. Our long distances, our small loads, our minute economies make many routes unviable and uneconomic. And in this situation, the government must either provide the shipping service or subsidise commercial operators to work on these routes. So this is a cross-section of the type of ships operating in Fiji today. From very small fiberglass boats with outboard motors to large old roll-on roll-off ferries, most vessels are beyond their service life. They're old, expensive to maintain and even more expensive to run. Many of our ships are that old, standards are not high enough, and we often end up with tragedies such as the Princess Ashika, which sank in Tonga, or the Rumble Queen in Papua New Guinea that sink with substantive loss of life. However, at the smaller scale and often unreported, small boats reliant on outboard motors are still used for large ocean trips in the Pacific, and when the motor breaks down or the fuel runs out, we lose crews on a regular basis. So if we look at Fiji as an example, this map shows the economic shipping routes in Fiji, the major routes between the large islands and the commercial centres. However, as you can see in this slide, many of the small isolated areas are uneconomic to run, and the government must provide subsidies or provide alternative shipping services. This is an extreme drain on national economies. So we've tried to demonstrate this pictorially about what options we have at the moment. If we start with the orange pie graph, this represents all the fuel that we bring into the Pacific. As you can see, the largest portion of this is for transport, a much smaller portion for electricity. There's a range of other smaller uses, industrial, home cooking, those sort of issues. But as you can see, transport is by far and away the biggest sector use. We don't have good data for a lot of our transport, and again, we're the inverse to global trends. If you look at the red pie graph, where we've broken down the transport sector by fuel use for Fiji. As you can see, air, closely followed by maritime use, are the biggest subsectors in the transport field. Land, of course, is much smaller in the amount of fuel that is used. However, because land is visible, land transport of course is visible, buses, taxis, trucks, cars, it gets most airplay. Marine transport so often fails to get the same priority given to it. The marine sector shown in blue is broken down into a number of uses: tourism, fishing, domestic transport, interregional transport. Interregional transport is generally regarded as reasonably adequate, but as you saw in the slides showing you the pictures of the different types of vessels available domestically, domestic transport, the connectivity of villages and communities, it must be our highest priority. So what options do we have for efficiency? There is a global revolution happening internationally as shipping tries to become more efficient with rising fuel prices and greater awareness of the environmental consequences of burning fossil fuels. And it's generally agreed by world experts that we have four means of increasing the efficiency of ships. The first is to use alternative fuels, and the world is moving towards LNG and methane as transition fuels towards the ultimate goal of hydrogen. However, these are poorly proven so far, and there is discrepancy between the reports from experts as to how effective and efficient such change will be. Unfortunately for the Pacific, none of these are real options for us tomorrow. The cost of providing infrastructure for new fuels such as LNG and methane is likely to be prohibitive for us to see it here in this region in the next generation. The second way of achieving efficiency in shipping is through operational change. Slow steaming is the practice of slowing the vessel down and greatly increasing its fuel efficiency, largely used by the entire world fleet in the last global financial crisis. Port efficiencies can be increased and reduce the amount of turnaround time for ships. Weather routing, that's choosing the route between two destinations to use the most favourable sea and wind conditions. Just-in-time routing, so the ship arrives and doesn't have to wait for days on end waiting for a port berth. Bulk fuel purchase across, all these are examples of operational efficiencies. And there is some room for us to improve our operational efficiency here in the Pacific, but many operators are already employing these practices today. The third efficiency method that's been identified internationally is the use of improved technologies. And there are dramatic increases being made in the efficiencies of hull designs, propellers, use of waste heat recovery, different technologies coming online at a rate of knots and very beneficial for large-scale, large ships. However, as most of the domestic fleet in the Pacific Islands is bought second, third, fourth or fifth hand, none of these advances are likely to be of dramatic use to the Pacific until they are available in another 20-30 years' time as second-hand options. So we've spent considerable amount of time and energy looking at the potential for renewable energy. Most experts agree that renewable energy has a significant role to play in the shipping of the future. They're also agreed that the greatest gains can be made at small-scale shipping size, the type of ships that we use here in the Pacific. The primary options that have been looked at are wind, solar, wave power, and the use of biofuels and biogases. And I've got a few examples of those here. They've come from a number of recent studies that have been produced by ARENA, by Lloyd's Register, and some by the Royal Academy of Engineering. This is a new invention for shipping in this generation.